My name is Andrew Knapp. I've been a manufacturing engineer at P1 Industries for a little over 9 years now. We had a pretty big project recently where one of our customers was doing a generator rebuild in the field, found a rather large component that had to be replaced called a blower shroud. Now this is a large casting that holds over 1,000 blades. While we're in the process of remaking this, obviously it's a 30-year-old generator, you cannot get the original castings anymore. So it's a rather complex shape, and the casting houses were struggling momentously to get a good casting that wasn't full of porosity. Now the customer and us were running out of time and we couldn't get a good casting, so we said, hey, we can fabricate this. We've made a lot of machine fabs in the past. Oftentimes when doing so, you can't just make it straight to the customer drawing or it won't fit together, so we're really used to the design aspect of making a machine fab go together. So when we suggested to make a machine fab to them, they said, okay, come up with a design and present it to us on Monday. And this was on a Friday. So over the weekend, I jumped on the computer, drew up a overlay of the original casting to a machine fabrication. Had to design all the components to it, so we started with some rolled plate, a bunch of laser blanks and machine parts to fit together and weld together to represent what the casting would have been. So they liked it, but what they did want for risk mitigation purposes was for a third-party registered professional engineer to evaluate the fab option versus the cast option. So we hired a local registered professional design engineer to run the FEA of the cast option versus the fabricated option to make sure that when it was installed, it would work. On the topic of risk mitigation, we had several steps in the process to make sure the part was good when it came out at the end. So the main dovetail groove where all the blades would be installed, we made sure that was out of one solid piece of rolled plate, which we had ultrasonically tested before it came in. Time being of the essence, we started with plate burnt out at a local shop, drop shipped to another local shop we worked with to roll the sections that would make the main part of the shroud. And that was then drop shipped to us. In the meantime, we got some other burnt outs for the parts that needed some milling before it was welded together. So when all of that hit the shop at once, it was ready to be welded and then put in a machine for the machine to start happening. We actually split the fabrication into 2 separate stages. Given the complex shape of this part, we didn't want to have to machine all the material out of there. So what we did was we took the inside rolled plates, a couple rings that would be attached to it, welded those together, welded them together in the machine, turned out most of the material because turning is the fastest way to remove material. Then we split that back apart, put all the puzzle pieces together that formed all the ribs and gussets, welded all that together, put it in our oven in the corner to stress relieve the whole assembly, and put it back on the machines to machine all the split lines and do all the finished turning. So after the final machining was done, we brought it into our paint booth. We painted all the unmachined steel surfaces for corrosion protection. And then we actually were able to test fit it to the mating part that they sent to us so that when it got to the field, they knew it would fit up. We also had to install all 1,008 blades into the assembly and get it all bolted back together and loaded on the truck and ship out before the end of November. And it was loaded on the truck at 11:53 p.m. on November 30th, so just in time. To meet the deadline of November 30th required people to even come in over Thanksgiving weekend. I mean, we didn't let anyone work on it on the Thursday of Thanksgiving so they could spend time with their families. But Friday, Saturday, Sunday, and Monday, it was all hands on deck. We probably had 30 people in this company worked on this project from start to finish. And even at the end, this is the kind of company we are, even some of the sales team came in to help install the blades to make sure this got on the truck when it had to get on the truck. Of all the work that was done on the blower shroud, probably the highest stress was the people doing the critical turning and milling features, which happened over next door. In fact, let's go over and talk to one or two of them now. So this is Cody. He probably had the highest stress of anyone working on this project. He runs a big, scary vertical lathe, and the part was just about the biggest part we could fit inside it. He had basically everyone kind of looking over his shoulder, wondering how it was going, and had to approach the part with the caution appropriate of a part that simply could not be scrapped.
The blower shroud was probably one of the most complex parts not in the part itself, but the fact that we had so many facets of the company working on it together. And it's a different type of stress when day in, day out you have to make parts and you have to hold tolerances and you can't scrap stuff. That's just part of the industry. But when you know there's hundreds of hours of machining, fabricating, pre-planning, and it all comes down on your shoulder because it's in your machine and you're turning all the features to where all the blades have to go into, and making sure that when you put it in the machine, you're holding it away. When it comes out of the machine, it's still the same shape, because you can influence a part that big and not have a good part after it comes out, because it has to go back together to disassemble it and put all the blades into it and then pre-package and ship it. That particular part was to the extremes of my machine's capability. I mean, I can turn out to 78 inches and the OD was 65. My chuck size is 57 inches, or 57 inches. So the whole part was actually on the outside part of my chuck. So we had to use a plate we made for it. And the height was 35 inches and I have 35.43 of travel in my Z. So it was literally the extreme stroke of my machine. So when you're going through a part like that, you have to try and anticipate it, but there's always going to be stuff that you run into. And that's what we did. And I think our company, we had a very good response to all of the issues and problems that came up, and we all worked really well together to get through them.